Hi everybody. Before we begin today's lesson, let's start with a warm-up. Without using a calculator, I want you to divide using long division and show all your steps. So hit pause, try the problem, and then hit play when you're ready to resume. All right, now 9 doesn't go into 3, but it does go into 32. It goes into 32 3 times. So 9 times 3 is 27. So I subtract 27 from 32. Now notice I put the 3 over the 2 in 32 because I'm dividing 32 by 9. So I subtract and I get 5. Then I bring down the 7. Now 9 goes into 57 6 times, which is 54. That leaves me with 3. Then I bring down the 3. 9 goes into 33 3 times, which is 27. Now 33 minus 27 is 6. Now, when you were first learning long division, your teacher taught you to say R6 for remainder of 6. However, when you got a little bit older, your teacher said, well, instead of remainder 6, we're going to take the remainder and write it over the divisor. So that became 363 and 6/9. Now, 6/9 reduces to 2/3. So our final answer would be 363 and 2/3. Now, that begs the question, does 9 go evenly into 3,273? So is 9 a factor of 3,273? The answer is no, because there was a remainder. So 9 is not a factor of 3,273 because there was a remainder. We want you to keep this kind of in the front of your mind as we go through this lesson, because now we're going to see how this relates to what we're doing today. So today we are doing day 3, notes 5B.3. We are going to be dividing polynomials through long division, synthetic division, and then we're going to be talking about the remainder theorem. Okay, example 1. They want us to use long division to simplify 3x cubed plus x squared plus 5 divided by x minus 2. So to set up long division, we're going to get our division bar set up and everything. Now, the numerator of that fraction represents the dividend. The numerator of that fraction represents the dividend. The denominator represents the divisor. So the dividend is the stuff underneath the division symbol. The divisor is what goes on the outside. Now, if you notice, if you look at your problem, you have an x cubed, an x squared, and then your constant. You are missing a term in decreasing sequential order. You're missing an x to the first term. So what we're going to do is we're going to add a 0x. Now, you may be wondering, well, doesn't that change the value? Well, no, because 0 times anything is 0. So I'm adding a 0. I'm changing what it looks like, but I'm not changing its value. So now I have x cubed, x squared, x, and then my constant. Now, my divisor, that's x to the first and a constant, so we're good. No need for a 0 term there. Now, when we start the division process, you have to take the first term of the divisor and you compare it to the first term of the dividend. So you have to say what times x will give me 3x cubed. And the answer there is 3x squared. Now, you may be wondering, well, why did you put it over the second term and not the first? Because this is a binomial, so since it has two terms, I start my quotient over the second term. Now we're going to do a big old distribution. We're going to say 3x squared times x, and then 3x squared times 2. So that gets me 3x cubed minus 6x squared. Now, notice that I put 3x cubed minus 6x squared in parentheses. And that's because I'm not just subtracting the 3x cubed, I'm actually subtracting the quantity 3x cubed minus 6x squared from 3x cubed plus x squared. So what I'm going to do is I'm going to have to distribute that negative across the parentheses. So I change the subtraction to addition, and then I change the sign of both terms. So here you'll see that 3x cubed and minus 3x cubed cancel. So then I add down the column, and I have x squared plus 6x squared is 7x squared. Now I bring down the next term. So now I have to say, okay, what times x gives me 7x squared? And that answer is 7x. So again, at this point, I do a big old distribution. Boop, boop. So 7x times x is 7x squared. 7x times minus 2 is minus 14x. Now again, we're subtracting the quantity. So I change the sign to addition and make that negative, then positive. Again, the x squareds cancel out, and I add down the column, and I get 14x. Now I bring down the 5, and I say, okay, well, what times x gives me 14x? And the answer is 14. Now again, I do the distribution. So 14x is, or 14 times x is 14x. 14 times negative 2 is minus 28. Again, add, change, change. So the x's cancel out, and 5 plus 28 is 33. Now the way we're going to write that solution is we are going to take 33 and put it over the divisor and add it back to the original problem. So instead of saying R33, we're going to say plus 33 over x minus 2. And that is our quotient right there. Okay, now, is 2 a root? And you may be wondering, well, where did that 2 come from? Well, your divisor could be a factor. So if x minus 2 is a factor, then that would make x equals 2 a root. So if x minus 2 is a factor, that makes x equals 2 a root. Now let's go back to the beginning. Was that 9 a factor of the dividend? And the answer was no, because we had a remainder. So we look up here and we're like, well, we've got a remainder, so x minus 2 can't be a factor. Therefore, x equals 2 is not a root. So if there's a remainder, when you set that divisor equal to 0 and solve, then that value is not a root. Let's do another one. Use long division to simplify 4x cubed plus 3x squared minus 20x minus 46 divided by x squared minus 5. So I look at my numerator, 3, 2, 1, constant. We're good. No need for a 0 term. However, look at the divisor. Look at that denominator. X squared and then 5. Well, we're missing the x term again, so we have to put in a 0 term. You've got to put in the 0 term. So now I have 2, 1, and 5. Even though that one is 0, at least I have a placeholder. So now I'm ready to start. And I have to say, okay, what times x squared gets me 4x cubed. And the answer is 4x. Now notice I put it over the third term because my divisor has 3 terms. And now I do distribution. So 4x times x squared is 4x cubed. 4x times 0x is 0x squared. And then 4x times negative 5 is minus 20x. So let's erase my drawings. So now remember, we're subtracting the whole quantity, not just that first term, but we're subtracting the quantity. So I have to go addition, change, change. Now you're probably like, well, what about 0? 0 is neutral, so it doesn't matter if you're adding or subtracting, it's the same thing. So I just changed the sign inside. So now you'll notice that the x cubes cancel, and I add down the column. 3x squared plus 0x squared is 3x squared. Now, negative 20x plus 20x is 0. And you're like, do I have to put that? You do. So now we bring down the 46. So we have minus 46. So now x squared and 3x squared. What times x squared gives me 3x squared? The answer is 3. So now I'm going to take and I'm going to multiply 3 by that trinomial. So 3x squared is 3x squared. 3 times 0x is 0x. 3 times minus 5 is minus 15. So now what we're going to do is we're going to change that subtraction to a plus, and we're going to distribute that negative. So positive or plus, negative 0 doesn't matter, plus 15. Now we notice when we add down the column, those pretty much go away, and I have minus 31 or negative 31. So when I go to write my remainder, I'm going to say minus. You could say minus or plus a negative, doesn't matter. 31 over x squared minus 5. And that is your quotient. Now, could I say that x squared minus 5 is a factor? Well, remember, to be a factor, you can't have a remainder. Did I have a remainder? Yeah. So I can't say that x squared minus 5 is a factor of that polynomial because there was a remainder. Let's look at another long division. They want us to divide 2x cubed minus 3x squared minus 2x plus 3 by 2x minus 3. So the first term is my dividend. So I go, x cubed, x squared, x to the first, constant. We're good, no 0 terms. Let's look at 2x minus 3. Linear than constant. We're good, no need for 0 terms. So let's start. What times 2x would give me 2x cubed? X squared. So I put it over the second term. Now I have to distribute x squared times 2x and x squared to minus 3. So that gets me 2x cubed minus 3x squared. Now remember, you have to take and you have to do plus and then change the signs inside. Now, right here you notice that in this case, they both cancel out, but you're only allowed one cancellation per level. So what you want to do is you want to leave that as 0x squared. So yes, they both cancel out, but you can only technically cancel the first term. So when you add down the column, I end up with a 0x squared. Then I bring down the minus 2x. And I have to say, okay, what times 2x will give me 0x squared? Well, the term is 0x. So I put in a 0x. Again, distribute. So 0 times all of that is 0. And since it's zeros, you don't really need to distribute. You can to keep, the pattern going. But negative 2x minus 0 is negative 2x. Now I bring down the 3. And you may be thinking, well, that second step was like stupid because it didn't really help. Well, remember, you can only bring one term down at a time. So you can't bring the negative 2x and the positive 3 down at the same time. By having that 0 term in there, you can bring down the minus 2x. Now on that next step, you can bring down the plus 3. So I say, okay, well, what times 2x gives me negative 2x? And the answer is minus 1 or negative 1. So then I distribute negative 1 to both terms in the divisor. That gets me negative 2x plus 3. Well, again, add, change, change. And when I add, change, change, I get 0. Now, when you are writing your quotient, you can drop the 0 term and you can say it's x squared minus 1. Now, could I say 3/2 is a root? Now you're like, okay, wait a minute. Remind me where 3/2 came from. We're saying if this is a factor, when we solve and get 3/2, so if 2x minus 3 is a factor and we solve that for x, we get 3/2, then that would become a possible root. So if 2x minus 3 is a possible factor, that makes x equals 3/2 a root. So is it? The answer is yes, because there was no remainder. There was no remainder. Remainder of 0. All right, so there's our quotient, and there is our answer to is it a root. Okay, so that was long division. Let's talk about synthetic division. Synthetic division is a lot like long division, but here's the cool thing. You're only messing with the coefficients, okay? So you are only playing with the coefficients. You don't have to worry about the variables and their exponents until the very end, okay? So now here's the key point though. You can only use synthetic division when you're dividing by a linear factor. So if you think about our second example, we were dividing by x squared minus 5. Well, x squared minus 5 is not a linear term. That's a quadratic term. So we can only divide by a linear power, meaning we're dividing by an x or a variable that the highest power is 1. So let's look at how we do this. So they want us to divide 2x cubed plus 3x squared minus 4x plus 15 by x plus 3. So this is what your factor will look like when we're dividing. Okay, it'll have x to the first as the biggest term. Now, we still want to be cognizant and look out and see, do we need 0 terms? So I look at my dividend, x cubed, x squared, x 15. There's no missing terms, so I don't need to put a 0 in. Now, when you synthetically divide, again, you're only messing with the coefficients. So let's take this step by step. So we're going to use only the coefficients and the constant to set up. Now, instead of dividing by the factor, okay, so instead of using the factor as our divisor, we're going to use the possible root. So you take what you're dividing by, you set it equal to 0, and you solve for x. So for synthetic division, we're only going to use our coefficients, and then we take the divisor, solve for x, and that's what we're going to use. So with synthetic division, you always set up an upside down division symbol. I mean, I don't think that's really what it's called, but that's what it looks like. But you want to make sure that you have enough room for 2 rows. So don't just make it a little one. You want to make sure that you have 2 rows available in your upside down division bar. Okay, so on the first row, what you're going to do is you're only going to take the coefficients. So it's going to, with their signs. So it's going to be 2, 3, -4, and 15. Notice I did not do any variables, just the coefficients and constant. So 2, 3, -4, and 15. And if you'll recall, instead of using x plus 3 like we do in log division, we're going to set that dude equal to 0, and we're going to divide by the possible root. So we're going to divide by -3. Okay, so you set the divisor equal to 0 and solve, and that's what you divide by. So we're going to divide by -3. Now, the first step, and you always want to do this so you don't make a mistake. Underneath the 2, you're going to put an arrow, and that's to keep you from writing anything in that spot. So what you're going to do is you're going to pull down that first coefficient. You're going to pull down that first number, the 2. So, and like I said, I always put the arrow there, so my mind goes, nothing can go there. So we pull down the first number, and then we say, okay, -3 times 2 is -6. So -3 times 2 is -6. Now I'm going to put that -6 underneath the second term. And now I'm going to add down. So 3 minus 6 is -3. Now I'm going to repeat with the -3 that's in blue. So -3 times -3 is +9. I then am going to put 9 underneath the 4. -4 plus 9 is +5. Then I'm going to put a little bar before I get to my last term. Now, I always like to do this before I get to my last term, and you're going to see why here in just a second. So now I'm going to repeat and do -3 times 5, which is -15, and add down the column. So the reason I do that is because the very last column, the number that's there, that represents your remainder. Okay, that represents your remainder. Now you're like, well, how do I get this back into a polynomial? Let me show you. So basically, you noticed when we divide by x, we knock everything down a power. So 2x cubed plus 3x squared minus 4x plus 15. If we divide each of those terms by x, that's going to become an x squared, that's going to become an x, that's going to become a constant, and then this will be some sort of fraction if it's not 0. Okay, so here's what we do to write the answer. So we're dividing by a linear factor. So when we divide by a linear factor, it knocks every exponent down by 1. So the first terms represent the coefficients of the answer, the quotient. So again, don't forget to decrease it by 1, and that represents the remainder. So let me erase my writing here. Okay, so I started with an x cubed, so I start down here with an x squared. So that becomes 2x squared minus 3x plus 5 with no remainder. So we started with an x cubed, so then we just start with an x squared, and we go down in sequential order. And then, of course, if you'd had a remainder, you would put it over x plus 3, but here it's 0, so we don't need it. So could we say -3 is a root? The answer would be yes, because the remainder was 0. If the remainder was anything other than 0, then it would not be a root. But we can say yes, it is, because we had a remainder of 0. Okay, let's try another one. They want us to divide 3x cubed plus 2x minus 1 by x plus 1. So I'm looking and I'm like, well, I have an x cubed, but then an x. I'm missing my x squared term. So if this was long division, I would write it as 3x cubed plus 0x squared plus 2x minus 1. So I still have to have a 0 term. So that way, when I write my coefficients, instead of going 3, 2, 1, I'm going to have to write 3, 0, 2, negative 1. So even with synthetic division, you've got to put that 0 term in if you're missing something. Now, x plus 1. Remember, x plus 1 equals 0, so that means we're going to divide by negative 1. Now, we're ready to start. Remember, we always pull down the first number. Okay, so pull down the first number and put a little arrow right under him so that way you know I don't write anything here. So negative 1 times 3 is negative 3. So I put that negative 3 under the 0 and add down the column. 0 minus 3 is negative 3. Now, negative 1 times negative 3 is positive 3, and I put that underneath the 2. 2 plus 3 is 5. Now, I put my little remainder bar there, so I know, hey, this is the last term. Whatever comes after that's the remainder. So negative 1 times positive 5 is negative 5. Add down the column, and I get negative 6. Okay, according to the rules, I started with an x cubed, so I knock it down a degree, and that becomes x squared, x, and my constant. And this time, I have a remainder. So that becomes 3x squared minus 3x plus 5 minus 6 over x plus 1. Now, could I write that plus a negative 6? Absolutely. Same answer, just looks a little different. But yes, minus 6 or plus a negative 6. Now, could I say that negative 1 is a root? Well, I have a remainder. So if I have a remainder, it can't be a root. So therefore, the answer would be. Okay, let's look at how we can factor the sum and difference of two cubes without using the rule. Now, if you love the rule, you don't have to use this. We're just showing you, oh my gosh, if you don't like the rule, you can actually do it with synthetic or long division. So they want me to factor x cubed minus 27. Well, if both terms are perfect cubes, then you want to get the first factor by taking the cube root of each term. So x cubed minus 27, the first term is x minus 3. Now, I don't know what goes in the trinomial because I'm not using the rule. So what you're going to do is you are going to take x cubed minus 27, that's going to be your dividend, and x minus 3 will be your divisor. So obviously I'm missing an x squared and an x to the first, so I have to put 0 terms in. So it'd be 1, 0, 0, negative 27. And then you take x minus 3, set it equal to 0, so you're going to be dividing by 3. I pull down the first term. 3 times 1 is 3. 0 plus 3 is 3. 3 times 3 is 9. 0 plus 9 is 9. Put my little remainder bar. 3 times 9 is 27. I got a remainder of 0. So if you've done this right, you should get a remainder of 0. You started with an x cubed. So for the answer, you start with an x squared. Okay, you start with an x squared. So that becomes x squared, x, and your constant. So to write the whole factored polynomial, you take the divisor times your quotient, and that's the same thing you would get if you did the rule. Now, showing you the same thing with long division, okay? So, x minus 3 times what? So, again, I have to put in x cubed minus 27 is the dividend, and x minus 3 is your divisor. But again, you have to put in 0 terms. So that would be x squared, so plus, negative, positive, boom. That would be 3x squared. Bring down the 0x. X times what is 3x squared? That's 3x. Distribute the 3x, so plus, negative, positive. And I get 9x minus 27, so I add 9, and I see that I have no remainder. So you'd still end up with x minus 3 times x squared plus 3x plus 9. So that's how we derive the formula. So we're like, well, we can do this for any and all perfect cubes, sum and difference, and this is how we get the answer of the factors. So just another way to get around it. Let's talk about the remainder theorem. Okay, the remainder theorem allows us to determine if something is going to be a possible factor or a possible root. So what we're going to do is let x minus a be a possible factor. Okay, x minus a is a possible factor. Well, if x minus a is a possible factor, then that means a is a possible root, because remember x minus a equals 0, so x equals a. So if x minus a is a factor, a is a root. Now, what the remainder theorem tells us. So let's think about this. If this a is a root, that means it's an intercept, which means it should equal 0 at that point. So your intercept would be a comma 0. So that means when I plug a into the given polynomial, it should equal 0. So if when I plug a in, if I get 0, then it's a root, also an intercept, because there is no remainder. Because remember, if it's a root, there's no remainder. So if I plug the a in and I get 0, that means that a is a root. If I plug it in and don't get 0, then it's not a root, because that means I have a remainder. And it just ends up, if I don't equal 0, it's going to be a point on my curve. It's just not going to be a root. So let's look at this example. P of x equals x to the 4th minus 5x squared plus 4x plus 12. And I want to know, is negative 4 a root? So that means I'm going to take negative 4 and substitute it into the equation. So I get negative 4 to the 4th minus 5 times negative 4 squared plus 4 times negative 4 plus 12. So I clean all that up, and I get 256 minus 80 minus 16 plus 12. I add all of those together, and I get 172. So since I didn't get 0, it's not a root. Okay, I have to get 0 for it to be a root. So what does it mean for this equation and graph? Well, like I told you, it's a point on the curve. It's negative 4, 172. It's just not a root or an x-intercept. Okay, now I'll show you if, again, I was missing. Now for remainder theorem, you don't need that 0 term because you're just plugging and chugging. But if you were to test it through through synthetic division, you would see that you get the same answer. So look here, I get 172 and 172. So it doesn't matter if you use the remainder theorem or the synthetic division to determine if it's a root. Okay, unless we say, hey, use the remainder theorem, or hey, use synthetic division. All right, but just to show you, you get the same thing if you plug -4 in versus doing the synthetic division. Now, here's the one thing about remainder theorem. It's not going to give you the quotient like synthetic division does. So synthetic division is going to tell you if you have a remainder, but it's also going to give you the resulting polynomial that you get through division. Okay, remainder theorem is just going to go, hey, it equals 0, or hey, it doesn't equal 0. But it's not going to give you that x cubed minus 4x squared plus 11x minus 40 plus 172 over x plus 4. Okay, it's not going to give you the quotient. It's just going to tell you, do you have a remainder or don't you have a remainder? Okay, let's look at another one. Is x plus 1 a factor of p of x equals 2x to the fourth plus 6x cubed minus 5x squared minus 61? Now, if all I want to know is it a factor, then yeah, remainder theorem is the way to go, because they're not asking me, hey, divide it. They're just saying, is it a factor? So I take x plus 1, set it equal to 0, and I get x equals -1. So if x plus 1 is a factor, that means -1 is going to be a root. So I'm going to take -1 and test it. So the first way, I'm going to do the remainder theorem, because like I said, they don't want to know the quotient. They just want to know, is it a factor? So I'm going to plug in -1 and simplify it. So -1 to the fourth is 1, 1 times 2 is 2, -1 cubed is -1 times 6 is -6, -1 squared is 1, 1 times -5 is -5, minus 61, and we get -70. So since I didn't get a 0, it can't be a root, aka intercept. So since it doesn't equal 0, it's not a factor. Okay. Now you could do it also with synthetic division. Now I have 4, 3, 2. I'm missing an x to the first term, so I have to put in a 0 term, and I use -1. Pull down the 2. -1 times 2 is -2. 6 plus -2 is positive 4. -1 times 4 is -4, which is -9. -1 times -9 is positive 9, which is 9 when you add down the column. Put my remainder bar. -1 times 9 is -9, which we get -70. So even using synthetic division, we're still going to arrive that we have a remainder of -70. Okay, so if we want to know it's a factor, I mean, we could even do long division, but that's just like, you know, a root canal. So if you want to test if it's a factor, there's the remainder theorem, or you could do synthetic division. Now remember, remainder theorem doesn't give you the quotient. It just says, hey, it's a factor. Hey, it's not a factor. Whereas synthetic division will give you the quotient and tell you if it's a factor. Just depends on what you're wanting to do. Okay, so you are probably wondering, how does all this come together? How does this help us solve a polynomial? Well, we are going to use synthetic division and or remainder theorem to help us turn something we can't factor into something we can. Because if you look up, even factoring by grouping, that would not help us. So, solve x cubed plus 2x squared minus 11x minus 12 equals 0, given that x plus 1 is a factor. Okay, so if you already know that it's a factor, you can just jump straight into synthetic division and go. However, on our day 4 lesson, all you're going to see is that. So on your day 4 lesson, you're not going to have any of this. We'll just simply say, hey, solve this polynomial. And so that's when you're going to use a possible root and use remainder theorem to test if it is a root without having to bust out synthetic division. Okay? So now don't panic, because on day 4, I'm going to show you how to get a list of possible roots. It's not very difficult, but I'm going to show you how to get that list of possible roots. Okay? And then we'll take that list of possible roots and we'll use remainder theorem to show how to test if it's a root. Okay, so we'll say, hey, here's 5 roots that it could be, and you plug them in and see which ones equal 0. And then you'll take the one that equals 0 when you do remainder theorem, and you'll use synthetic division to break it down. However, today we've already done that step for you, so don't panic. I just wanted to tell you kind of where this is all leading and where it's kind of coming down the pipe here. So again, we've already done that first step for you. Now on day 4, we're going to show you how to do that first step. But we've already done the remainder theorem, and we know that x plus 1 is a factor. We know that one works. So what we're going to do is we're going to take synthetic and we're going to knock it down to it's something that we can factor and solve. So basically, we're going to do synthetic division because we already know x plus 1 is a factor. So I'm looking and I go x cubed, x squared, x constant. Awesome. So what I have to do, and we know it's not factorable, so I'm going to use synthetic division to reduce it to a quadratic. Because remember, if I start with x cubed, then it knocks it down to an x squared, and I know how to handle a quadratic. So I do 1, 2, negative 11, and 12. And then remember, we set the divisor equal to 0, and I get x as negative 1. So we're going to do synthetic division with negative 1. So you pull down the 1. Negative 1 times 1 is negative 1. 2 minus 1 is 1. Negative 1 times 1 is negative 1. Add down the column, and I get negative 12. Put your remainder bar. Negative 1 times negative 12 is 12. So I get a remainder of 0, which I should get a remainder of 0 because I'm telling you this is a factor. There's no is it or isn't it. It's, hey, I know this is a factor. So if I know it's a factor, I should get 0. Now remember, this becomes, I started with cubed, so this becomes x squared, x, and constant. So I now have a quadratic. X squared plus x minus 12. Well, I can factor that. That's x plus 4x minus 3, which means I get x equals negative 4 and x equals positive 3. So again, if you can't factor it though, you could do quadratic formula or complete the square. Okay, but likely for me, this was factorable. Okay, so now remember back from 5b1. Our exponent tells us the number of solutions, so I should have 3 solutions. But right here, I only see 2. Wait a minute, though. If it's a factor, it's a root, which means if it's a root, it's a solution. There's our third. So therefore, my solution set is negative 4, negative 1, and positive 3. Okay, last example. They want us to solve x cubed plus 4x squared minus 3x plus 2 equals 0, given that x minus 1 is a factor. So I already know it's a factor. I know it works. So I don't have to test and get possible factors, because for today, we're giving you the first factor. We're taking that first step for you, telling you, hey, this works. Now use synthetic division to bust it down to a quadratic and solve that quadratic. Again, on 5B.4, we're going to show you how to do that first step. But for now, don't stress. We're doing that for you. So, okay, we know x minus 1 is a factor. So I'm looking 3, 2, 1, 0. Okay, so no missing terms. So 1, 4, -3, -2. And then set this equal to 0. I get x is 1. So I'm going to do synthetic division with 1. So I pull down the first term. 1 times 1 is 1. 4 plus 1 is 5. 1 times 5 is 5. -3 plus 5 is 2. 1 times 2 is 2. And we get 0, which we should because we know it's a factor. So that gives me a quadratic. So x squared plus 5x plus 2. Now that's not factorable. I really do not want to complete the square, so I'm going to do quadratic formula. And when you do quadratic formula, you get x is -5 plus or minus the square root of 17 over 2. Now you're like, wait a minute, you told me that that exponent tells me the number of solutions. That's 2, but don't forget about him. He is a solution. So I say 1, and then you can just write it as a kind of a combo, -5 plus or minus the square root of 17 over 2. All right, so that's kind of a sneak peek into what we're doing on 5B4. All right, so that concludes the lesson for today. Your homework is 5B.4. I lied, it's 5B.3. That's my bad. So your homework is 5B.3. You have a quiz next class period over 5B1 to 5B3. So make sure you're ready for that. And please make sure you wash your hands, wear your mask, social distance, and make good decisions. All right, guys, have a great evening or a great day or whenever you're watching this video. Have a good one, and we will see you back next time. Bye, guys.